am back. Yeah, once again back. Yeah, it has been a while. And yeah, of course, got to pay the bills, got to keep working. And work is kind of taking over my ability to do YouTube videos. But got a little bit of time now, so I'm going to hop in here, get y'all a video. And today, going to be looking at Increasing Triplet Subsequence from Leetcode, and it is a Python exercise. Increasing Triplet Subsequence. Yeah. It's a good one. So, given an integer array nums, return true if there exists a triple of indices I, j, and k such that I is less than j less than k, and nums index I is less than nums index j and less than nums index k. So we need to find three, I guess you could say, elements or indices where the indices are increasing as they go up and the values are increasing. So the values of the elements and the indices are going to be increasing. So of course it's going to go, I will be the low index and k will be the higher one. And then the values are going to be going up as well. So increasing indices and increasing values. So that is the stage. So let's look at the examples. Example 1, nums is 1, 2, 3, 4, 5. These are all increasing. And of course, indices always increase left to right. So any triple is going to be valid here. Whether it's 3, 4, 5, 2, 3, 4, 1, 2, 3. Take your pick. Any triple here, any triplet is valid. Fits into this increasing triplet subsequence. So this is all good. Very, easy to eyeball that one is going to work. Looking at example 2. 5, 4, 3, 2, 1. You notice as you go up in indices, these are all descending. So no triplet exists because you're not increasing left to right. So there's no possibility of a higher index having a higher value than a lower index. It ain't happening. Let's look at example 3. 215046. There's a triplet at 3, 4, 5 index or indices 3, 4, 5 because nums 3 is 0, nums 4 is 4, and nums index 5 is 6. And that's going to be right here, index 3, 4, 5. Of course, the indexes go up 3, 4, 5 as they always do, left to right. The values are going up as well. 0 is less than 4, and 4 is less than 6. We got our triplet. There we go. Now we got to figure out how to do this programmatically, not just eyeballing. Yeah, so this is where the elite coder skills are becoming in. Yeah, so let's hop over here. Try this thing out. Actually, we're going to dominate. We're going to kill this thing, actually. We're going to destroy it. Okay. A thing right off the bat, because we're getting a triplet subsequence, meaning we're looking for 3 things, 3 indices and 3 values, it's got to be 3. So the first thing I'm going to do is check that there are at 3 unique values in this list. Because if there are not 3 unique values, then we can just stop right there and say false. So here's how I'm going to do it. I'm going to do it by taking the list and turning it into a set via the set function. Then I'm going to check and see if the length of that set is less than 3. If the length of the set is less than 3, then there are not enough unique values in the list to continue. So it'll look like this. If that is less than 3, then we're returning false, because if you don't have 3 unique values, you cannot develop an increasing triplet. If they're all the same, you have 3 ones, there's no increasing value. If there's like 2 2s and 1 1, that's only going up 1. So there's not enough. So got to be at least 3 unique values. So that'll eliminate some of the issues there right off the bat, as they say. So now I'm going to get into my regular, I guess you could say, strategy. I want to illustrate it for you really quickly. Let's say this is our list or array. We're going to start traversing with the variable I. And, maybe I will start at 0. Let's say I begins traversing at 0 because it's going to, like when we start. For each I, we're going to create, we're going to go in deeper and do a variable j that begins at I plus 1, and then the j will go forward. And then for each j, we're going to create a k, which is j plus 1 that goes forward. And what we're going to try to do is, for each I, we're going to have j traverse the rest of the list to see if there is a j that is greater than I. And then for each j, we're going to have a k variable that traverses the rest of the list to see if there's a k that's greater than j. To see if we can develop, this kind of thing where not only indices but values. And when I say greater than, when I said it earlier, I'm talking about values. We're trying to find values. We're going to do this via nested loops, where we're going to have an I loop, then a j loop, and a k loop, where I is going to go forward, and then j is going to go forward 1 past I, and then k is going to go forward 1 past j. So we will do nested looping, and you guys are going to see what it is right now. I'm going to leave you in suspense for the rest of it. Take that off. Let's go. Alrighty. Start my for loop. So talking about the end of the limit of my outer loop, I'm going to limit it at -2 because I want to leave at least 2 places for j and k, because you're going to need to have 2 elements that are higher indices and greater than I value-wise. So I is not going to need to go all the way to the end. It'll end at -3, which is where this is going to end. The length of -3. So that leaves the length of -2 and the length -1 for j and k. And we're going to do a k loop, or sorry, a j loop. Nope. I'm going to start this one at I plus 1 because we're looking for values in the list that are at a higher index and a greater value than where I is. So of course J is going to need to start higher than I. So it'll start I plus 1, then it'll go length. This will go length -1 because you want to leave 1 over for K. Good. Okay. All right, now, so I've got a J loop, or yeah, going past I. I want to check if I found a value with my J index that is higher than a higher value than what my I index is holding. So I'm going to do this. Oops. Because if I have a J that has a higher value than what I currently has, then I'm part of the way to my solution. I found one increasing value. So if I find that one increasing value, I'm going to start another loop, because I want to loop further past the J and see, now can I find an element with a value higher than J, so that I can complete the triplet I, J, K. So I'm going to do a K loop. And this one, it's going to start at J plus 1, because it's got to be past J, because the index, of course, is got to be higher. But I'm going to go the full length, or all the way to the end, because I have nothing to leave space for at the end. So I'm going to just do length of nums. And then here, this will be my final if condition, where I'm going to see if I find a K value that's higher than my current J value, I've completed my increasing triplet subsequence. Yeah, so I'm going to do that. If nums K is greater than nums J, then I got my triplet. I'm going to return true. So I've got this kind of like cascading nested loop. It almost forms like a right triangle or something. But hey, it is what it is. And this is not a very efficient way to do it, but I think it's easier to follow and easier to explain than some other ways. And right now I don't have another way, because I haven't figured another one out. So when you guys figure them out, you can post them, put links, whatever, in the comments. Feel free. I'm all ears. So we found our triplet on line 10, apparently. So if you don't find the triplet, you're going to return false, because this returns a Boolean, true or false. So let's do that. Because really, if you go all this length through all these traversals and you don't find a triplet, you got to return false. Yeah. So let's see if this one works. I have a good feeling that it will. Aha. K greater than J. What's my runtime error? Oh yeah. Oh wow. Yeah, my indentation's screwed up. Indent that. Indent that. Alrighty. Alright, the basic cases have passed. Now I'm going to try to submit. Alright, that passes. As you can plainly see, at the bottom of the list as far as efficiency, but hey, it got accepted. That's a step in the right direction. So the code works. So I'll leave it up to you to be way more efficient than this, but at least you got a solution. At least you got a pathway as far as how to do this one, but there are much better ways. But I thought this was an interesting problem, and I had a little difficulty with it here and there, but it was a good learning experience. So triplet, let's say Increasing Triplet Subsequence. Whoops. Yeah, this one's done. You can see the code. And yeah, with that, I am done. See ya.